Good morning students. You are all welcome to today's online class. I am so glad to meet you after a long day. I hope you are all safe by the grace of God. Are you happy students? Are you interested to learn mathematics? In the previous year due to corona disease we couldn't conduct the exam, isn't it? But anyway, you should have the thorough knowledge of 9th syllabus. Let us recall some basic definitions what you have learned in the previous year. Okay. So in the previous year you have learned the lessons in mathematics, set language, real numbers, algebra, geometry, coordinate geometry, mensuration, statistics and probability, isn't it? That same chapters continuation only we are going to learn in the 10th standard also. Okay. Today some basics we are going to learn. So, do you remember the definition of a set? So, let us recall the definition of set. What is a set? Set is a collection of well-defined objects. Okay, what is a set? Set is a collection of well-defined objects. Okay, set is a collection of well-defined objects. Set is a collection of well-defined objects. Can you say the example for set? Yes, isn't it? The total number of students in our Bethlahem Matric school can be say one set. Okay. Example. The total number of students in our Bethlahem Matric Higher Secondary School. Can you see one more example? Can you guess? Collection of English alphabets. How many English alphabets are there? Do you remember? We have 26, is it? That is a one well-defined set. So, can we say collection of, let us take this is number 1, then number 2. Collection of English alphabets. Okay. Set is a collection of well-defined objects. Okay. Example, the total number of students in our Bethlahem Matric Higher Secondary School. It is the well-defined set. Okay. We can define how many number of students in our school. So, that is the set. Second example, collection of English alphabets. We know that there are 26 elements in English alphabets. That also well-defined set. So, set is a collection of well-defined objects. Next, we are going to recall the types of set. What are the types of set we have? Empty set or null set. It is denoted by the sign pi or empty set. First of all, empty set or null set. It is denoted by the symbol pi or this is empty set. Next type we have singleton set. Singleton set. Example, A is equal to any one element. I have chosen here 2. A set having only one element is known as singleton set. Next type, finite set. Finite set. A set having countable number of terms. Example, 1, 2, 3. Any other elements we can choose. Next type, infinite set. Next type, infinite set. For example, I have chosen here natural numbers. It starts from 1 and 1, 2, 3, etc. etc. There is no end, so it is set to infinite set. Okay. So let us recall the types of set. First, empty set or null set. It is denoted by the symbol. This one is pi or the symbol, empty symbol. Okay. Empty set. Next one, singleton set. Set having only one element. Any one element we can choose. I have chosen example, the set A is equal to 2. Only one element is there, so it is known as singleton set. Next, finite set. Set having countable number of terms. For example, I have chosen here 1, 2, 3. Set A is equal to 1, 2, 3. Finite. There is a end, so it can be said finite set. Next, infinite set. A set having uncountable number of terms. For example, natural numbers, it starts from 1 and there is no end, 1, 2, 3, etc., 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 which is the last number we cannot say. So it is known as infinite set. Let us write the definitions one by one. So you can take the rough note and you can write along with me. Okay. First one, empty set. Empty set or null set. Null set. A set consisting of no element is called the empty set or null set or and also it is called the void set. One more name is there, void set. Sometimes it is asked to void set, you have to answer. A set consisting of no element is called the void set. Okay. It is denoted by the symbol pi or null set symbol, this one. There is a one word question. Are the sets 0 and this null set are empty sets? Can you say the answer? Is it empty set? No. There is an element, is it? There is only one element, that is 0. So it is the singleton set. It is not an empty set. It is the singleton set. What about this? Is it empty set? No. This also, there is only one element is there, that is pi. So it is also known as singleton set. Okay. No. It is singleton set. Okay. Next, let's write the definition of singleton sets. What is meant by singleton sets? A set which has only one element is called a singleton set. A set which has only one element is called a singleton set. A set which has only one element is called a singleton set. Example, only one element means we can say the set of all even prime numbers. What are the set of all even prime numbers? There is only one even prime number, which is that the set of all The set of all even prime number. What is that? A is equal to the set A is equal to only one even prime number we have, that is 2. 2 alone. Okay, so only one element it can say singleton. What is meant by prime number? Do you remember? The numbers having only 2 factors, means 1 and itself. What about the number 1? 1 is neither prime nor composite. What is meant by composite number? Numbers having more than 2 factors are known as composite. What is meant by prime numbers? Numbers having only 2 factors. What are the factors? 1 and itself. For example, 3 means the number 3 is 3 having 2 factors. 1 and 3. 1 and itself. So what are the prime numbers? 2, 3, 5, 7, 11, 13, 17, 19, etc. etc. What are the composite numbers? Numbers having more than 2 factors are known as composite numbers. Can you say the composite numbers? What are the composite numbers? Numbers having more than 2 factors. So 4, 6, 9, 12, 15, etc. etc. Okay. What about the number 1? 1 is neither prime nor composite. Okay. It has only one factor. Next, finite set. A set with a finite number of elements is called a finite set. A set with finite number of elements is called a finite set. Example, can you say what is the definition? A set with a finite number of elements, means countable number of terms. Example, set A is equal to 1, 2, 3. 3 numbers are there, is it? Countable number of terms. This type of sets can be say finite set. One more example. The set of indoor or outdoor games you play. That also countable numbers. So this also can be say finite set. Next, infinite set. A set which is not finite is called an infinite set. A set which is not finite is called an infinite set. Infinite set. Not finite means what? What is meant by this? Uncountable number of terms. For example, we can say natural numbers n is equal to 1, 2, 3, etc. 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 Last term we cannot say, we cannot define, etc. etc. There is no end. Okay. So this type of sets can be say infinite set. And also one more example can be say whole numbers. Whole numbers are starts from 0, 0, 1, 2, 3, etc. etc. No end. This type of sets can be say infinite set. So what is the difference between finite set and infinite set? In the finite set there are countable number of terms, and in the infinite set there are uncountable number of terms. In the finite set we can define the number of terms. How many terms are there we can define. In infinite set we cannot define. There is no end. Understood? Next, union of two sets. The union of two sets named A and B. A and B is the set of all elements which are either in A or in B or in both. It is denoted by A union B. How to read this? A union B. What is the union of two sets? The union of two sets A and B is the set of all elements which are either in A or in B or in both. It is denoted by A union B. By Venn diagram, let us consider the universal set and name it U. There is two smaller sets A and B. A, B. If you want to show your A union B, we have to shade both the sets together. Okay, the shaded portion is shows as A union B. Only this shaded portion is known as A union B. Okay, the union of these two sets A and B is the set of all elements which are either in A or in B or in both. Both means this common part, this part. Okay. Next, intersection of two sets. The intersection of two sets A and B is the set of all elements common to both A and B, and it is denoted by the symbol A intersection B. How to read this? A intersection B. By Venn diagram, let us show the intersection. The intersection of two sets A and B is the set of all elements common to both the set A and B. Okay. Only common part we have to select. By Venn diagram, it is the biggest set, that is universal set. Inside this universal set, let us consider the two sets A and B, two joint set A and B. To show the intersection, we have to take only common part for A and B. Which is the common part? Only this center part is the common part. So only the shaded portion is the A intersection B. Understood? Next, difference of two sets. Let A and B are the two sets. The difference of sets A and B is the set of all elements, which are in A, but not in B. It is denoted by A difference B. Like this can write. This can be read A difference B or A minus B or A difference B, like this. Okay, how to read this? A difference B. By one diagram I am explaining you, easily you can understand. A and B be two sets. The difference of sets A and B is the set of all elements which are in A but not in B. So A difference B means the set of all elements which are in A but not in B, except B. So by the Venn diagram I am explaining, you can understand easily. So let us draw the universal set, bigger set, universal set. There is a two joint sets, A and B, A, B. So we have to show the A difference B. The definition is telling which are in A, not in B. So except B, this is B. This full set we have B. So we should not touch the set B, except B. Remaining is the A difference B. So remaining part we have to shade. Only shaded portion is the A difference B. A difference B. A difference B or A minus B. A and B are two sets. The difference of sets A and B is the set of all elements which are in A but not in B. So A minus B in the sense except B. Okay. So this B set completely we should not shade. Remaining we have to shade. That is A minus B except B. Okay, understood? Similarly, we can find the B minus A. What is meant by B minus A? B minus A means except A. So this complete A set we should not shade. Remaining we have to shade. Okay. So this part alone. So B minus A means except A. Understood? Next, Cartesian product of two sets. For example, A is equal to 1, 2, 3. Any value can be taken. Okay. B is equal to 3, 5. Here also any other value we can take. Not only 3, 5. As service any value can be taken. A also. As service any 2 value or 3 value, 4 value, etc. Whatever as service we can take. I have chosen here A is equal to 1, 2, 3. B is equal to 3, 5. Let us find the Cartesian product of A and B. That is A cross B. A cross B is equal to, how to find the A cross B? Listen carefully. It is related to our syllabus, 10th syllabus. Okay, A cross B is equal to, first of all we have to give the set bracket. Then this first element and this first element. Okay, that is 1, 3. And this first element and this second element. 1, 5. After that, this first element and these two elements over after, then second element. The second element 2 and this first element 3. And the second and the second element 2, 5. What is the next? 3 and 3. 3, 3. Then 3, 5. 3, 5. Then we can close the bracket. It is A cross B. How to read this one? A cross B. Similarly, we can find the B cross A also. If they asked to find A cross B, only this much you have to write. Okay. And also, if they asked to find B cross A, we can find B cross A equal to, first of all we have to write the B values. B is 3, 5. So 3, 5 cross A is 1, 2, 3. 1, 2, 3. Let us find B cross A, which is equal to, first of all set bracket, then 3, 1. 3, 1 first set, then 3, 2, then 3, 3. Next 5, 1, 5, 1, 5, 2, 5, 3. Okay. So next question. If A cross B is equal to 1, 2, 3, 4, 2, 8. Any other numbers we can find A and B. Last question. A and B values given, A cross B we did and B cross A also we did. Is it? In this question A cross B is given. What is A? What is B? We are going to find out. Okay. So how to find out now? Given A cross B is equal to 1, 2, 3, 4 and 2, 8. What is A? What is B now? A is the set of all first coordinates of A cross B. What is the first coordinates here? 1, 3, 2. So A is equal to 1, 3, 2. All these first elements. Okay. B is the set of all second coordinates of A cross B. Therefore, what is B? B is equal to second coordinates. What are the second coordinates? 2, 4, 8. So B is equal to 2, 4, 8. Okay. B is equal to 2, 4, 8. Okay. These are the today's chapter. That worksheet will be sent through WhatsApp. Okay. So revise the today's chapter. Okay students. Next we can continue in the next class. Thank you students.